A security researcher named Onan Guan typed a single instruction into the title of a normal GitHub pull request. He hit submit. Within minutes, 3 of the most prominent AI tools in the world, Anthropic's Claude, Google's Gemini, and GitHub's Copilot, read his instruction and executed it. The agents identified and retrieved the host repository's secret API keys, posting them as a public comment for anyone to see. There was no external infrastructure required to do this. There was no malware and no brute force exploit code. It was just plain text embedded in a common workflow. The attack is now known as comment and control. The web has become a hidden instruction layer for the machines we've built to read it. Every page an agent visits now carries the potential to override its internal programming. To understand how 3 elite security agents were compromised simultaneously, we have to look at how a language model actually parses a document. This diagram illustrates the core flaw, known as indirect prompt injection. On the left, a human naturally separates the article they are reading from a random command buried at the bottom. On the right, an AI processes both the intended content and the hidden text in the exact same context window. To the model, both look like valid input. As the visualization shifts, you can see what happens when that hidden text contains a confident instruction. The AI parser treats the embedded command as a primary directive, overriding its original security guardrails to follow the new rules. Attackers conceal these instructions, shrinking text to a single pixel, draining color to match the background, or using hidden CSS tags. The AI parser reads the raw HTML and registers commands completely invisible to human eyes. The conversational reasoning that makes an AI useful, its ability to interpret open-ended natural language, is the exact unpatchable bug making it vulnerable. Out on the open web, attempts to exploit this mechanic have surged 32% in just 3 months. Security researchers recently documented 10 distinct payloads actively deployed right now. One payload embeds a specific PayPal URL, a fixed $5,000 amount, and step-by-step transaction instructions designed to hijack AI financial assistants. Another targets AI coding assistants that operate with shell access. It hides a Unix command designed to force the recursive deletion of files and directories within a developer's local environment. This timeline chart shows the math of the invisible war. The window from a vulnerability being discovered to a working exploit being deployed has compressed violently. A process that took 5 months in 2023 now takes 10 hours in 2026. This acceleration is driven by frontier models doing the offensive heavy lifting. Autonomous systems are reading new security papers, understanding the flaws, and generating working exploit code at machine speed. Traditional cybersecurity relies on having weeks or months to develop and distribute patches. That reaction timeline is now functionally obsolete against AI-augmented attackers. Enterprise security teams are realizing that prompt injection cannot simply be patched out of a model. They are treating it as a chronic condition, much like human phishing. The primary mitigation strategy is extreme privilege management. An agent operating with the ability to process payments or execute terminal commands must be locked down to the absolute minimum permissions required for that single task. Companies are pairing this with anomaly detection platforms, specifically tuned for autonomous agents. Analysts watch for the exact moment an AI assistant makes an unusual network call or accesses a sensitive file. Yet, an attacker only needs to subvert an agent's logic once to bypass the entire security stack from the inside. Based on the volume of payloads already in the wild, the defensive community expects a catastrophic, publicly disclosed breach within the next 12 to 18 months. The target will likely be a major Fortune 500 company, resulting in massive data exfiltration or direct financial theft. When losses move from hypothetical risks to documented billions, the regulatory conversation follows. A breach of this scale would likely move AI security from a niche research topic to a focus for mandatory compliance and liability standards. We are rushing to give artificial intelligence the power to execute tasks autonomously on our behalf. Those extraordinary capabilities carry severe, built-in security flaws. Right now, isolated AI agents are continuously scanning web pages, emails, and repositories, moving through an environment seeded entirely with invisible threats.